Good morning, all. Today we have derived density of states. So if you have any doubts, so that I want to clarify it. So I'm recording this video. Density of states. It is defined as the number of available energy states per unit volume in an energy interval E and E plus dE. And it is denoted by Z of E. It is given by the number of energy states between the energy E and E plus Di in the metal piece divided by volume of the metal piece. So already we've seen this diagram in the class, but in order to clarify your doubts, again I'm just telling what is this diagram. You have to imagine a metal piece of side A and A. Inside you have to imagine a sphere, radius N. And you have to imagine a rectangle, 1 by 8 of the sphere. Here, you have inner shell and you have a outer shell. What is the origin? Nx, ny, nz for the coordinate axis. N is the radius of the inner shell. Dn is the radius of the small interval, this interval. Okay, so E is the energy of the inner shell, and then E plus dE is the energy of the outer shell. But dE is the energy in between this gap, inner shell and outer shell. So here what we are going to calculate is, we are going to calculate the number of, or we are going to derive the number of energy states in between this inner shell and outer shell. So how many number of available energy states in between this inner shell and the outer shell we are going to calculate. We are going to derive. So for this we have to consider a cubical metal of size A. In order to find the number of energy states available in between E and E plus dV, a sphere is considered with three quantum numbers nx, ny, and nz, whose inverse nx, ny, nz for the coordinate axis. And here shows the origin, and all the points on the surface of the sphere have the same energy E. So therefore, the number of energy states within the sphere of radius n is given by 4 pi 3 pi n cube. It is the volume of the sphere. Since the quantum numbers nx and ny, nz can have only positive integers. Only 1 by 8 of the spherical volume has to be considered, because only that one octant of the sphere have all these quantum numbers nx, ny, and nz as positive integers. Therefore, the number of energy states with one octant of the sphere of radius n corresponding to energy E is given by 1 by 8, 4 by 3, pi n cube. Similarly, number of available energy state within one octant of the sphere of radius n plus dn corresponding to the energy state E plus d is given by 1 by 8, 4 by 3 pi, n plus dn the whole cube. So now you have to see the number of available energy states in between these two shells. Already we are going to calculate in between these two shells we are going to derive. So what we have to do? This minus this volume of this n plus dn minus volume of this n. So n of Eg is nothing but number of available energy states in between E and E plus dE is given by 1 by 8, because 1 by 8 is common, so I am checking 1 by 8. 4 by 3, 4 pi by 3 is also common, so I am checking the 4 pi by 3. N plus dn the whole cube minus n cube. Now 4, this 8 will be cancelled, so I'm getting pi by 6, and n plus d and the whole cube is like the formula a plus b the whole cube. So n cube plus dn cube plus 3n square dn plus 3dn 3n dn squared minus n cubed. See the formula? Since dn is already small, so the higher powers dn squared and dn cubed are neglected. Second, write number of energy states between E and E plus dE as n of E dE 5 by 6, 3 n squared dn. So this 3 and 6 will get cancelled. So it will become pi by 2 n squared dn. So number of available energy states can be written as n of n of E g is equal to pi by 2. This n squared and splitting, we have to split into n into n dn. So this is your equation number 4. And we already know the energy of an electron, the cubical metal piece which finds A is given by E is equal to n squared h squared by 8ma squared. Here A squared, so n squared is equal to 8ma squared E divided by h squared. This is your equation 5, this is your equation 6. Checking root on both sides, so n is equal to 8ma squared E divided by h squared, the whole power 1 by 2. This is the equation 7. Now, we have to differentiate equation 6 so that we will get 2ngn is equal to 8ma squared dE divided by h squared. ngn is equal to 8ma squared dE by 2h squared. This is your equation 8. Now, substituting equation 7 and 8 in equation 4, we have number of energy states is equal to pi by 2 h ma squared e by h squared the whole power 1 by 2 h ma squared d by 2h squared. So if you 1 by 2 and pi by 4, that will become pi by 2, it will become pi by 4. 8ma squared d the whole power 1 by 2 into 8ma squared by h squared the whole power 1. So 1 by 2 plus 1, it will become 3 by 2. So pi by 4, 8ma squared by h squared the whole power 3 by 2 e power 3 by 2 into g. Because already we have seen the number of energy states divided by the volume is the density of energy state. So number of energy states divided by L cube is equal to, here it is actually L is A. L is nothing but A. Both of the sides of the metal piece. So here we will be having pi by 4 8m by h squared the whole power 3 by 2 e power 1 by 2 dE into L. L is nothing but A. So here L cube, this L cube will get cancelled. So n of E d is given by pi by 4 8m divided by h squared the whole power 3 by 2 e power 1 by 2 d. So here L is equal to A. A and L are equal, both are same, both are the side of the cube. According to Pauli's exclusion principle, the two electrons of opposite spin will occupy a quantum number. So, density of state is given by 2 into pi by 4 8m divided by h squared the whole power 3 by 2 e power 1 by 2 into d. So, two electrons are considered with opposite spin will occupy a quantum state. So, we have to consider the two electrons. So, the density of energy state is given by 0 g is equal to 2 into pi by 4 8m divided by h squared the whole power 3 by 2 e power 1 by into d. So if you multiply with 2, because we are considering 2 electrons, so density of state is given by pi by 2 8m divided by h squared the whole power 3 by 2 e power 1 by 2 into g. So this is the derivation of density of state. Thank you.